Germany has recently unveiled a brand new air defense system that is already drawing comparisons to, and in some respects even outperforming, the American Stryker M-SHORAD platform. This development is significant, not just because it showcases Germany's growing emphasis on layered air defense, but also because it highlights how modern militaries are rethinking short-range protection against the rapidly expanding threats posed by drones, cruise, missiles, helicopters, and low-flying aircrafts. To understand why this German system is making waves, it's worth breaking down its design, features, performance, metrics, and unique innovations in a way that both military enthusiasts and a general audience can grasp. At the core of this new German system is its modularity. Unlike legacy short-range systems that were often locked into a single vehicle platform or restricted to one type of sensor or missile, the German design emphasizes flexibility. It can be mounted on different vehicles depending on the mission profile, from lighter armored vehicles to heavier carriers, giving commanders more freedom to deploy it in varied terrain and operational contexts. This modularity extends to its weapon loadout as well. The system integrates a mix of missile interceptors and rapid-firing guns, with the option to add directed energy weapons in the future. That means it's not stuck relying solely on missiles, which are highly effective but expensive. Instead, it can choose the most efficient tool for the threat at hand. Another standout feature is its advanced radar and sensor suite. Germany's engineers have invested heavily in multi-mode radar that can track small, low-observable drones that typically evade conventional detection systems. The radar is designed to rapidly switch between wide area scanning and focused tracking, so operators can manage multiple incoming targets at once. Beyond radar, the system also employs electro-optical and infrared sensors, giving it the ability to function effectively even in environments with heavy electronic warfare interference, where traditional radar might be jammed. This sensor fusion creates a comprehensive picture of the battlefield and significantly boosts the system's ability to engage fast and unpredictable aerial targets. Performance-wise, the German system excels in reaction time and precision. One of the biggest challenges in short-range air defense is how quickly the operator and the machine can detect, identify, and engage a threat that could be traveling at hundreds of meters per second. The German design streamlines this process through advanced automation. Once a target is identified, the onboard fire control system can calculate the most effective interception method almost instantly. If it's a cheap quadcopter drone, the gun system or a proximity fused round can take it out economically. If it's a more sophisticated cruise missile, the system switches to guided interceptors with pinpoint accuracy. This layered engagement strategy gives Germany a significant advantage, especially as the skies are increasingly filled with diverse threats rather than just traditional aircraft. Design elements also reflect modern battlefield needs. The German system is mounted on highly mobile armored platforms with excellent off-road capability. Unlike static air defense systems of the past, this one can keep up with mechanized brigades, advancing with tanks and infantry fighting vehicles without slowing them down. It's built for survivability, too, with modular armor that can be upgraded or adapted depending on the threat environment. Mobility and protection combined mean this isn't a system that sits back and waits. It actively maneuvers with frontline units, giving them a protective shield against aerial threats at all times. Comparisons to the American Stryker M-SHORAD are inevitable, and here's where Germany's system stands out. The US platform, while impressive, is largely centered around integrating existing technologies onto the Stryker vehicle with Stinger missiles, a 30mm cannon, and a mix of sensors. It works well, but the German system goes a step further by emphasizing interoperability with NATO's integrated air defense architecture. This means it's not just protecting one unit, but can be networked into a larger grid, sharing radar data, passing along target information, and even coordinating missile launches with other systems in the field. That level of integration makes it a force multiplier. Another element worth noting is Germany's focus on cost-effectiveness. Missiles are expensive, and using them against cheap drones creates an imbalance in cost versus effect. To solve this, the German system integrates programmable ammunition for its gun component, which can be set to explode at precisely calculated points near the target. This makes it incredibly efficient for downing small, fast, and inexpensive drones without wasting multi-million-euro interceptors. Over the long term, this approach reduces operational costs while maintaining a high success rate in terms of range and altitude coverage. The German system is designed to protect against threats up to medium altitude while focusing strongly on the short-range layer. This bridges a critical gap between man-portable air defense systems like shoulder-fired launchers and long-range systems like Patriot batteries. In modern conflicts, this short to medium range is where most threats exist: drones, loitering munitions, and low-flying cruise missiles. By filling that gap effectively, Germany is enhancing its layered defense network in a way that ensures no single threat type can exploit weaknesses. The firepower itself deserves attention. The gun is usually a 30mm or 35mm autocannon, capable of firing airburst munitions. These rounds can be pre-programmed to detonate in front of or near the target, spraying it with shrapnel in mid-air and neutralizing it before it reaches friendly forces. Combined with rapid fire rates, this makes the gun ideal for drone swarms or multiple incoming projectiles. The missile component complements the gun by extending reach and ensuring the system can handle tougher or higher value threats. The ability to mix and match these capabilities is what makes the German design stand out. Another unique selling point is the system's future-proofing. German developers have already stated that the platform is being prepared to integrate directed energy weapons such as high-energy lasers. These systems, though still in development, promise virtually unlimited magazines, since they rely on electricity rather than physical ammunition. By designing the system with space, power generation, and cooling capacity in mind, Germany is ensuring that when these technologies mature, they can be slotted in seamlessly without requiring a complete redesign. This makes the system not just advanced for today, but adaptable for the battlefield of tomorrow. Crew, ergonomics, and usability are also thoughtfully considered. The interior is designed for rapid operation with minimal stress. Automation reduces the cognitive load on the crew, meaning fewer people are required to operate the system effectively. Displays combine data from multiple sensors into a single coherent interface, so the crew isn't overwhelmed by conflicting streams of information. This focus on ease of use not only increases efficiency but also reduces training time, making it faster to field new units and integrate them into active brigades. Germany's defense industry has also emphasized reliability and maintainability. A weapon system is only as good as its uptime, and the German approach uses modular components that can be swapped in the field quickly. Instead of requiring long repair cycles in depots, faulty components can be replaced on-site, minimizing downtime. That logistical advantage ensures the system remains combat-ready even in prolonged campaigns. When looking at performance under stress conditions, the system demonstrates resilience. It's designed to operate in contested electromagnetic environments, where adversaries might attempt to jam signals or spoof radar. The multi-sensor suite, along with encrypted communications and robust software, makes it harder to neutralize through electronic warfare. This resilience ensures that even in sophisticated conflicts against near-peer adversaries, the German system remains effective. One cannot ignore the symbolic aspect either. By developing such an advanced system, Germany is signaling its intent to take a stronger role in NATO's defense posture. For decades, Germany has been criticized for underinvesting in its military, but this system shows a shift toward not only catching up, but also innovating ahead of allies. In particular, the focus on drone defense aligns with the lessons learned from Ukraine, Syria, and other recent conflicts, where inexpensive unmanned systems have become a decisive factor on the battlefield. Another layer of uniqueness is the system's digital backbone. Germany has designed it with open architecture software that allows upgrades through patches and updates rather than hardware overhauls. This is critical because threats evolve quickly. A drone design that wasn't a problem 2 years ago might suddenly become a top priority today. With open architecture, the German system can adapt by uploading new targeting algorithms or refining engagement logic without waiting years for a new version to roll off the production line. The export potential of this system also cannot be overlooked. Many nations are urgently seeking affordable, effective ways to protect themselves from drones and cruise missiles. By combining cost-effective engagement options with cutting-edge technology, Germany has positioned itself to become a major supplier in this defense segment. NATO allies in particular may be drawn to the system because of its interoperability, ensuring it can plug seamlessly into shared defense networks. On the design side, aesthetics may not seem important, but they reflect function. The German system features a compact turret that minimizes radar signature and reduces weight. The vehicle platform is designed for rapid transport, capable of being airlifted if necessary, which increases its strategic mobility. For operations requiring rapid deployment, this is a critical advantage. The emphasis on sustainability is another subtle but important feature. The German system has been engineered to work with hybrid electric power in the future, reducing its logistical footprint and making it more environmentally conscious compared to older fuel-hungry systems. While this might not matter much in combat, it reduces costs and aligns with broader national goals for greener defense solutions. What makes all of this particularly striking is how quickly Germany has developed the system. The pace reflects urgency, clearly informed by current geopolitical realities, with Russia's war in Ukraine highlighting gaps in European air defense. Germany, as pushed to field the system superior in many ways to the U.S. Stryker M-SHORAD, shows a clear determination to close vulnerabilities and ensure its forces are protected against both current and future threats.